Most modular houses are based on modules that are assembled from wood frame elements. This type of construction solution has many advantages. Firstly, frame elements are slim because insulation and utilities can be installed within the frame, saving space while maintaining the structure's load-bearing capacity. Secondly, the elements are lightweight, which provides advantages in transportation, advantages in lifting operations, a slimmer foundation solution. Thirdly, modular construction shields structures better from weather and reduces significantly construction time on site. As well, factory quality control is more systematic and thorough than on-site inspections. And finally, in the case of a solution based on a wooden frame, less energy is consumed and less carbon dioxide is released into the atmosphere. This is due to the weight of wooden structures. The lighter and slimmer the building, the less carbon dioxide is released into the air during the production process, during the transportation of materials and final products, and during the construction of foundations. Modules that do not contain a bathroom or shower room are called dry room modules. Dry room modules are easier to manufacture and generally have fewer utilities. The floors in dry room modules in living spaces are mostly covered with parquet, and in some cases, PVC or linoleum is used, for example, in healthcare facilities. The heating system uses radiators, convectors, and solutions for electric or water underfloor heating. Dry room walls are typically covered with plaster boards, which are usually finished with a paintable wall covering material. Wallpaper is rarely used. In public buildings or dormitories, panels made of wood fiberboards with a finished surface have found use. The ceiling in a dry room, just like the walls, is covered with plasterboards that are painted. Additionally, acoustic suspended ceilings or wood fiber or metal panels with a finished surface are also used on the ceiling if needed. The base structure of walls and ceilings in a wet room may not differ much from that of a dry room, but the floor construction and the materials used to cover the structures are different from those in a dry room. Wet rooms need to be constructed in such a way that the high humidity in the rooms does not penetrate the boundaries or damage the structures. Therefore, all surfaces needs to be waterproofed: the floors, walls, and ceilings. Floors and walls need to be hydro-insulated. That can be achieved either a strong moisture-resistant fabric or, quite often, a mastic with specific thickness is applied on the surface. Ceramic tiles are usually installed on top of the waterproofed surface. Sometimes wall or floor covering vinyl is used. In this case, no additional waterproofing is needed. It's important to note that a ceramic tile wall covering is not a vapor barrier and doesn't provide waterproof layer because its joints may contain microcracks and allow vapor and water to penetrate, so waterproofing is always necessary beneath the tiles. The ceiling in a wet room, however, has a different solution, as it generally consists of two parts: the main ceiling and a suspended ceiling. The main ceiling behind the suspended ceiling is covered with moisture proofing. Ventilation ductwork and electric cables are also attached here. In the case of small living spaces, a ventilation unit as well. The suspended ceiling, which covers the technical utilities, is generally made of mineral wool or compressed wood-based boards, moisture-resistant plasterboards, or another similar decorative materials. If necessary, an access hatch is installed in the suspended ceiling for access to technical equipment. If needed, modules can easily be connected to each other in a way that several modules form one large common space. This approach is used in school buildings to create classrooms and in kindergartens for playrooms, or in open-plan apartments where the living room is combined with the kitchen area, resulting in a large shared space. The maximum width of a single room element is usually around 4 meters, but the length can extend well over 10 meters. When large spaces are desired, modules can be placed side by side, where the longer sides of such elements are left open. Normally, an element with large open sides would lose the required stability. Therefore, strong frames made of steel or engineered wood are installed in the construction of such volumetric elements to help maintain shape and ensure stability. A similar situation can also arise if, architecturally, the building is provided with openings covering a large part of the external wall, in which case the steel frame is integrated into the external wall of the module. In the case of taller buildings, following situations may also arise where a strong wind load affects the frame structure of a building to such an extent that in order to increase stiffness and stability, some of the boundaries must be made of CLT elements, engineered wood, or even a steel frame. Such hybrid solutions in modules are central to a single building, and the structure is calculated according to the loads acting on the building. With the construction industry leaning towards industrialization, identifying solutions that are both cost-effective and resource-efficient is a major challenge. Designers play a key role in this process by utilizing proven methods and developing new approaches. As one volumetric element, also known as a module, consists of several other elements, such as wall, floor, and ceiling elements, and it may be a dry room or a wet room. The assembly drawings are quite complex compared to two-dimensional elements. The assembly of the module, sometimes also referred to as the erection of elements, begins when the floor element, which supports all accompanying elements, has been moved to the erection area. Let's take a closer look at the assembly drawing of the module. As you know, a prerequisite for quality work is following thoroughly the technical drawings that are prepared by the designer. If any questions, don't hesitate to contact the supervisor or designer. In the following drawing, you will see a much more detailed description of the module. Typically, information related to the axes, joining elements, furnishings, and different joint solutions has been added to assist the worker in properly erecting the elements together. Axes of the building are reference lines that represent the main structural borders of the building. The axes of the building are the axis lines of the main load-bearing structures. They are used to ensure all elements of the building are correctly positioned. Using axes makes it easier to find your way around the building during design, element erection, and construction. You can refer to a part of the building that is on an axis, where two axes cross, or between axes. In the case of external walls, the axes are marked on the outer surface of the outer walls, while at the joints of the modules, the axis shows the conditional center line. The axes of the building are also necessary in order to mark the building down in nature before the start of construction work. The module as a whole consists of the floor, walls, and ceiling. Therefore, it is important to mark all related elements on the drawing. You see that floor and ceiling are not separately visible on the plan, but they are marked as text and symbols. This method simplifies the assembly drawing and avoids confusion, making it easier to focus on the details related to the assembly of elements. Since parts of the interior, like kitchen or bathroom furniture, may be installed in the module at the factory, these are also shown on the plan. Did you know that sometimes a module can be up to 95% complete before it leaves the factory? This means a lot of interior features, such as fixed kitchen or bathroom furniture, can be integrated into the module. Since openings are also installed on the modules at the factory, their designations are also marked on the plan. Of course, in every technical drawing, it is essential to carry out the dimensions of the element. This plan shows all the dimensions needed to build this particular modular unit. Both the side dimensions and the diagonal of the module, as well as the dimensions of the location of the internal walls. Diagonal measurements are important to ensure that the module is square. One of the most important part of the assembly drawing is showcasing how the different structural parts are connected to each other. For this purpose, the joint solutions of different parts of the elements have been prepared separately, and the corresponding markings have also been marked on the assembly plan of the module. For example, a joint explaining opening installation, like D812, can be marked at the opening. Or the joint of walls, like KD9, is shown at the corner of drawing. To see detailed instructions, you will find the joint solutions on the other pages of the technical drawings. At the junction of the walls joint, we can see with which screws the elements are connected and which is the step of screws. But as well, there is information related to fire and moisture sealant if they needed to be added. In the following page, you can find different type of joints. For vertical and horizontal joints, each one is serving the purpose to give detailed overview how to assemble the building components. The plan made to erect the module should have all the necessary information. If necessary, additional explanations can be found as sketches or textual references, like in any typical drawings. Depending on the company, the presentation of objects on the drawings can be quite different. Therefore, when starting work, one of the first things is to make it clear to yourself how to read the drawing and what is the most important information to you presented in the drawing. In previous chapters, we discussed how various planar elements that make up volumetric element, such as walls, floors, and ceilings, are manufactured. After all planar elements are completed, the next work section is to create a volumetric element from them. Before starting to assemble the module, it is essential to familiarize oneself with the module assembly drawings, work instructions, and the required tolerances. Different manufacturers may have different tolerance requirements. For example, the permissible deviation from the diagonal or length and height dimensions, or the deviation in the dimensions of opposite walls. Tolerances usually fall within the range of plus or minus 2 to 5 millimeters. Assembly of the module begins by transporting the floor element to the designated area. When carrying out lifting work, it is important to remember that handling a telfer is a specific task, and only a person who has done the relevant training works with it. This ensures not only safety, but also the correct use of the tool not to harm the building component. Depending on the specifics of the manufacturing process, the floor element can be either attached to the wheels or to the supporting beams. If the element is attached to the wheels, then it is moved to the intended place by pushing. With such a solution, the entire module under construction will later move on its wheels until the end of the production area, making intermediate stops for carrying out various work processes at the module. With this logic of the production process, the contractors of the different works are in one specific area, and when the necessary work is completed, the module is moved to the next area where the next work is performed. Such a production process is similar to the production process in car factories. In smaller manufacturing companies, a solution is used where the floor element and the module built on its basis are stationary. The floor element is lifted by a crane to the designated area. On the floor element, it is marked the locations where the wall panels must be installed according to the working drawing. If necessary, the end points of the markings must be shifted to achieve the right angles of the outer walls. It is important to make sure that the outer walls are located at right angles. If there are openings in the floor panel, such as a stairway or a shaft opening or both, the locations of the openings must also be checked either in relation to the walls or to the axes shown in the drawing. If it is intended that water pipes or electrical conduit pipes will go into the walls from the floor panel, then their position relative to the marking lines must also be checked. Once the marking lines have been drawn onto the floor panel, then the wall elements are raised using a telfer and moved to the location indicated on the floor panel. Before fixing the wall panel, a specially designed seal or adhesive must be placed in the joints of the wall and floor panel accordingly the drawings. In this way, the tightness of the joint is ensured. The wall element is fastened with either nails or screws and with the prescribed step and location, as well as according to the company's standard solution in this regard. When assembling wall elements, The prescribed erection order must be followed. This is showcased in the technical drawings. If the longer side of the wall element is attached first, followed by the shorter end to form a corner, it provides better stability for the erected wall elements. However, depending on the developed solutions, the installation order may also be different. The vertical level of the wall elements must be regularly checked in the process of their installation. To fix the position of the elements, additional supports are used. The joining wall elements are fixed with screws or nails according to the standard solution provided by the company or drawings. When installing the elements of the external wall, attention should also be paid to the placement of the vapor barrier film. Depending on the project, there may be several solutions, but it is important that the vapor barrier film forms a hermetic union with the floor panel, adjacent wall and ceiling panels to secure the module for any moisture damage. If all the wall elements are installed and fixed, then lastly, the ceiling element is raised in its place. The attachment of the ceiling element to the wall elements must also be airtight. The airtightness of the joint is ensured similarly to the floor, either with glue or sealing tape. Attention should also be paid to the vapor barrier film, as well as its connection with the vapor barrier of the wall element. Both the installation of the ceiling panel and all joints must be carried out in accordance with the technological solutions described on the company work instructions or developed by the project designer. After the assembly of the volumetric element, it is necessary to check the verticality and right angles of all surfaces. Verticality is checked with a long level, and right angles with a long square. All tolerances must fit within the tolerance requirements set by the company. Most often, the last work of the erection process is the sealing of the joints between board layers of elements. Here it is necessary to strictly follow the requirements of the project, because in addition to the airtightness requirement, the fire resistance of the joints may also be required. In case of fire resistance requirements, the joints of drywall must be sealed with fire-retardant mastic, for example, acrylic with fire resistance properties. In rarer cases, when the joints turn out to be very large, fire-retardant foam is also used for sealing. In this lecture, we will talk about the most important works that are done in the modules after they have been erected in the factory. As already known from above, the modules can be divided into two: dry room modules and wet room modules that includes shower rooms, bathrooms, or saunas. Considering the specifics of such modules, they demand various internal works. Typically, the internal works include adding to the module different communications, like electrical or ventilation installations, but as well water, heating, and sewage systems. Quite often in the modular units, interior finishing is also done, in meaning that walls and floors are covered with designated materials and solutions, and even the furniture is installed. Depending on the manufacturer, the order of work may be somewhat different, as it is important to follow the smoothness of the whole process. The electrical installation works in module are carried out accordingly to the working drawings. This includes installing electrical equipment like wires, switches, sockets, and lights. Note that all electrical works may only be performed by individuals with proper electrical safety training. Electrical wiring is placed inside protective tubes called conduits. If the conduits do not already contain pre-installed wiring, the wiring is pulled into them later. Using conduits makes it easier to replace the wiring in the future if needed. For external walls, it's crucial to maintain the building's airtightness. Therefore, electrical boxes should be installed within the vapor barrier. If this isn't possible, they must be airtightly sealed to prevent air leakage. In wet rooms, special care is needed as water and electricity don't mix well. When installing bathroom fixtures, it is important to know the locations of cables and other utilities to avoid damaging them. For example, ceilings contain lights and their power cables, as well as cables needed for operating the ventilation system. Walls have power outlets for appliances such as washing machines, dryers, or any other electrical appliances. If the bathroom has electric underfloor heating, then the heating cable is generally installed either in the concrete base plate or in the base of the ceramic tile in the mixture layer. When laying the heating cable, it is always necessary to take into account the location of the floor drain. The electrical wiring must be kept at a specified distance from the drain. In modular buildings, up to 95% of the ventilation system can be set up in the factory. Only the connection of ventilation pipes and system adjustments need to be done on site. For large buildings such as hospitals, schools, or nursing homes, more work is required on-site related to their central ventilation system and larger equipments. Modern buildings usually use a heat recovery ventilation system, which balances the amount of air entering and exiting rooms. This not only improves the air quality, but as well raises the energy efficiency of the building. Ventilation ducts are installed either in the ceiling structure, in plasterboard boxes in the ceiling corners, or behind suspended ceilings. Suspended ceilings are usually designed either in hallways or in damp rooms. In the bathrooms, the room temperature is generally higher than in other rooms, and relative humidity can easily rise up to 100%, where the air becomes saturated with moisture. Therefore, active ventilation is extremely important. During bathroom ventilation, the air enters the bathroom either through a grill in the door or through a gap under the door. Extraction typically occurs through a vent, which is usually located in the ceiling near the shower or bathtub, so that the moisture can exit close to its source. Once the modules are assembled on site, the pipelines are connected, and finishing work is done, as only then the ventilation system is finally adjusted for proper airflow. Multi-story buildings use communication shafts for heating pipes for domestic water and water heating, as well as ventilation and sewerage pipes and electrical cables. Depending on the type of building, it may be required that electrical cables need to be located in a separate shaft. Through the shafts, water pipes run into water or heating collector cabinets. From there, water is distributed to the intended fixtures, like sinks or toilets. The domestic water pipeline is usually located in the area of the wet rooms, kitchen, and in the case of larger dwellings also in a separate toilet room. The pipes are installed in the wall adjacent to the water consumer, such as a toilet bowl, sink, a washing machine, or any other appliance or fixture. For water pipes that are installed in the walls, as a rule, a pipe-in-pipe system is used. This means that the entire water pipe is enclosed with another protective pipe. In order to be able to make changes to water pipes later in the future, the protective pipe must be strongly fixed to structural elements, beams and posts. Sometimes water-based underfloor heating is used to heat a building or different rooms. In this case, various solutions can be used to install the heating pipe on the floor element, such as grooved boards, where the pipes fit snugly. As well, aluminum sheets can be used in the grooves to help distribute heat evenly across the floor. If the underfloor water heating is used in bathrooms, then, just like with electric heating, the layout of the heating pipes should follow the design plans, keeping in mind the location of the floor drain and the not be placed too close to the drain. The heating circuits are connected to a central collector cabinet, where the distribution and control of heating throughout the building is managed. In the bathrooms, the domestic water pipes are usually installed inside the wall element, but sometimes run along the wall's surface. The ends of the in-wall pipes are brought out at designated locations planned for water fixtures, such as a washing machine, sink faucet, or shower mixer. It is extremely important to seal the areas around the pipe penetrations because the moisture in humid and warm room moves easily through the gaps inside the wall construction and may condense there. Typically, a special gasket is used for this purpose, which fits tightly around the pipe or is glued with mastic to the wall's waterproofing. Sewer pipes in the shower area near the sink or toilet are located within the structure. The shower drain is managed through a floor drain. Since these drains are highly exposed to moisture, sealing around the drain must be done carefully to prevent any water leaks. The finishing process for walls and ceilings starts with applying putty. Depending on the manufacturer, some of the puttying work may also be done before the module is erected, for example in the case of walls that are assembled on a robotic line. Surface priming, puttying, and sanding are carried out in accordance with the company's work instructions. Although the final results of different manufacturers are similar, different materials and work techniques are used in the execution of the work, which are described in more detail in the work instructions. In dry rooms, in the case of plasterboard walls, previously puttied and sanded surfaces are covered with a finishing material, which is glued to the surface and painted after drying. Once wall and ceiling surfaces are finished, the corners need to be sealed. In the simplest case, corner moldings are used for this, which are fixed with slat nails. Other solution is to use corner reinforcements, which must be finished with elastic mastic to prevent the formation of cracks. Such a solution is more time-consuming, but the final result provides more refined finishing. If pre-painted wall or ceiling panels are used in the building, they are installed according to the manufacturer's instructions. The use of finished panels saves time and does not create dust or moisture in the installation places. Acoustic suspended ceilings are used in spaces where echo can be a problem, like in hallways, offices, classrooms, or hospitals. Acoustic suspended ceiling tiles effectively absorb and dampen sound waves and thereby significantly reduce the echo by making the space quieter. Using wooden boards for interior finishes is more labor-intensive, but it can create a warm and cozy atmosphere when matched well with the overall design. The walls of the bathroom on a wooden structure are designed in such a way that they can withstand both mechanical influences and prolonged moisture loads. In the case of a coating the walls with ceramic tiles, their substrate must be sufficiently rigid to avoid possible deformation and damage to the tile or tile joints. Therefore, the wooden frame is usually covered in 2 layers with building boards. For example, strong plasterboard or wood-based board is installed on the frame side and plasterboard on the room side. To prevent moisture damage in wet areas with ceramic tile finishes, it's essential to apply a waterproofing membrane to the walls before tiling. This typically involves a 3-step process. First, a primer is applied to the walls, followed by an installation of strong fabric and a coat of waterproofing mastic. Note that additional fabric is installed in the corners and joints of the plaster boards. To further seal and protect areas in the walls where pipes or electrical boxes pass through, additional protective cuffs are installed. Once the waterproofing has dried, ceramic tiles can be installed. When bathroom walls are covered with PVC sheeting, no additional waterproofing is installed underneath, as such covering is already a strong barrier against both moisture and water. Special attention must be paid to the PVC joints, ensuring they are strong and watertight, and that the areas around pipe penetrations and cable entries are securely sealed. In addition to ceramic tiles or PVC, moisture-resistant cladding panels can be used. In this case, it is necessary to be strictly guided by the installation requirements of a particular manufacturer. Ceilings in wet rooms are often lower than the main ceiling and are made from gypsum boards, suspended ceiling tiles, or panels that have moisture-resistant properties. Suspended ceilings hide building services attached to the main ceiling, such as ventilation ducts, water pipes, and electrical cables. Spotlights and ventilation covers are integrated into the suspended ceiling tiles. For this purpose, holes are made in the tiles at the appropriate locations for the installation of spotlights or ventilation covers. Floors can be covered with multiple ways, depending of its role related to the location in the building and interior architectural solutions. For example, roll-based floor coverings, such as vinyl like PVC or linoleum, are versatile and can be used in various types of spaces, like commercial spaces and educational institutions. But as well, tiling and parquet is used. In the following chapter, we will focus on roll-based floor covering and wet room floors. For roll-based floor coverings, the subfloor must be rigid and flat to prevent visible irregularities. The subfloor can be made of special gypsum board, a poured concrete slab, or a wood-based board, onto which the roll material or other intended material is glued. In case of unevenness, the subfloor must be sanded. Before installation, the material must acclimate in the room for at least 24 hours. Before installation of the covering, sheets of the necessary length and width are cut from the roll of material. Adhesive, designed for gluing PVC or linoleum coverings, is applied to the subfloor. Note that gluing is carried out according to the adhesive manufacturer's requirements and must be performed in accordance with the company's work instructions. The adhesive joint must remain strong, so the floor covering sheets can be pressed firmly against the subfloor. A heavy metal roller is a good tool for rolling the floor covering, which firmly bonds the covering to the subfloor. Once the covering is installed on the floor and the adhesive has dried for at least 24 hours, a groove is cut into the covering seams to install a welding cord to seal the seams and ensure the floor's durability. The welding cord is installed hot using a suitable tool. The welding seam ensures the tightness of the floor covering and must be installed according to the hot welding work instructions. For parquet-covered floors, the subfloor is first covered with a soundproofing material, which is usually made of wood fiber or mineral wool boards. A common thickness for wood fiber boards is approximately 7 millimeters. The parquet is installed on top of the soundproofing material. In the case of higher sound insulation requirements, an acoustic class wool board is used, which is covered in 2 layers with floor gypsum boards, less often with a concrete board. Either parquet or some roll material is installed on the boards. In the case of roll materials, the surface of the tiles must first be covered with a putty mixture and sanded. Then, the roll material is glued. The floors of wet rooms in modular buildings are typically constructed on either a poured concrete slab supported by a wooden frame or on prefabricated high-density wood fiber boards with a ready-made fall. A general rule is that the subfloor must be completely rigid and must not deform under heavy loads. The floors of wet rooms must have a gentle slope towards the drain in the general area with a steeper slope near the floor drain to ensure quick water drainage. Slope requirements can vary by country, but even in the wet zone areas. For example, around the trap and in the shower area, 1 to 50 slope might be required, while the rest of the wet room requires 1 to 100 slope. A 1 to 100 slope means a 1 centimeter drop over 100 centimeters, and a 1 to 50 slope means a 1 centimeter drop over 50 centimeters, creating a steeper angle. Waterproofing must be applied across the entire floor area and extended up the walls to a specified height from the floor surface, for example up to 15 centimeters. Waterproofing can be done either using a PVC-based material or a strong fabric coated with a waterproofing mastic. After installing the PVC covering, the seams must be carefully sealed. Sealing is done using hot air welding. The welding cord is melted into the joint, and the excess part is cut off. To prevent the PVC from staining the wall finishing work, protective tape is applied to the folded-up edge. Requirements for the vapor resistance, strength, and placement of waterproofing can vary somewhat from country to country. Therefore, it is always important to carefully follow the relevant requirements and regulations of the building's country of location. The work process for installing waterproofing on floors is similar to installing waterproofing on walls. However, as a rule, the requirements for the strength and thickness of waterproofing for floors are stricter than for walls. When using PVC-based or similar materials on a wet room floor, the installation process is similar to that of a dry room, and installing ceramic tiles on wet room floor follows a process similar to walls. The complexity is to consider floor slopes and drain locations to ensure proper water drainage and also prevent any water leaks. Furniture installation will begin once all finishing works are complete. Typically, built-in furniture provided by the manufacturer, including kitchen and bathroom cabinets, as well as other items like wardrobes and shelves, will be installed as agreed upon with the customer. Soft furnishings, chairs, and tables are usually not part of the house package. The installation of kitchen furniture requires great care and attention to detail as the furniture integrates various water and electrical appliances, such as a sink with taps and drainage, a washing machine, refrigerator, an electric stove, a ventilation system, lighting, and more. Therefore, the furniture must be installed by a qualified specialist who is aware of the installation requirements set by the building regulations to prevent potential accidents. Bathrooms are typically equipped with a toilet, a wash basin with a wall-mounted mirror cabinet, and either a shower enclosure or a bathtub. If necessary, a washing machine and dryer can also be installed. As bathrooms are high-humidity environments with surfaces covered in waterproofing, the installation of both water and electrical appliances must take this into account to prevent potential water leaks or the risk of electric shock. Additionally, the location of water drains must be considered. Typically, the layout of the bathroom fixtures is indicated on the project drawings,